In this video, we're going to talk about how to use the Poisson distribution formula in order to solve problems. So take this problem, for example. A small business receives, on average, 12 customers per day. What is the probability that the business will receive exactly 8 customers in one day? So the first thing you want to keep in mind is that the time interval is the same. It doesn't change. So thus the mean is 12 customers per day, or the average. Now some textbooks will use lambda for the mean. I'm going to use this symbol here. Now to calculate the probability, we're going to use this formula. Capital X is the random variable. Lowercase x in this case is 8. That's the probability that we're trying to calculate. We want to know what's the probability that the business will receive exactly 8 customers in one day. So x is 8. And the formula is mu raised to the x e to the negative mu divided by x factorial. So let's replace lowercase x with 8. So this is going to be 12 raised to the 8 e to the negative 12 divided by 8 factorial. Now, keep in mind e is the inverse of the natural log function, and e is basically a number. It's 2.71828. 8 factorial, that's 8 times 7 times 6 times 5, all the way to 1. So if you were to plug this into your calculator, you should get, hold on one second. You should get 0.065523, which if we multiply that by 100%, that's approximately 6.55%. So that's the probability that this business will receive exactly 8 customers in one day. Number 2, a student receives, on average, 7 text messages in a 2-hour period. What is the probability that the student will receive exactly 9 text messages in a 2-hour period? So what do you think we have to do in order to solve this problem? Go ahead and try it. Now, there's something that you need to pay attention to, and it's the time interval. Notice that the time interval, it doesn't change. It's the same. So therefore, 7 is the mean. Now the only other thing that we need to find is x. We can clearly see that x is 9 because we want to calculate the probability that the student will receive exactly 9 text messages in that 2-hour period. So we need to calculate p when x is 9. So let's go ahead and plug everything in. First, let's write the formula. So as we said before, it's mu raised to the x, e raised to the negative mu, divided by x factorial. So x is 9, mu is 7, so this is going to be 7 to the 9th power, e raised to the negative 7, divided by 9 factorial. So let's type that in. So you should get 0.1014, which correlates to approximately 10.14%. So that's the answer for part A. Now, let's move on to part B. But first, let's get rid of this information. What is the probability that the student will receive exactly 24 text messages in an 8-hour period? So notice this time, the time period is different. So therefore, the mean is going to change. The mean was 7 when the time period was 2 hours. what is the new mean value when the time period is 8 hours? So by looking at these values, you can see what it is. To go from 2 to 8, you need to multiply the 2 by 4. So therefore, you need to multiply the mean by 4, which will give you 28. 7 times 4 is 28. So that's the new mean value. Now sometimes the math will not work out as nicely as what we see here. So you could set up a proportion. If you want a formula to do this, you can use this one. Mu2 over mu1 is going to be T2 over T1. So we're trying to calculate mu2, which is, well, we're going to see that it's 28. Mu1 is 7, T2 is 8, T1 is 2. So let's cross multiply. 7 times 8 is 56, and this is going to be 2 times mu2. Dividing both sides by 2, we get 56 divided by 2, which is 28. Now let's rewrite what we know. So mu, we could see that it's 28, and x has to be 24. We want to calculate the probability that the student will receive exactly 24 text messages in this 8-hour period. So x is 24. So we're going to use this formula. P of x is equal to 24. That's going to be mu to the x. So that's 28 raised to the 24th power times e raised to the negative mu, which is 28 divided by x factorial. And so that's going to be 24 factorial. And this is going to be, the answer I got is 0.060095. So it's approximately 6%, or you could say 6.01%. So that's it for question 2 of this video. Number 3, a small business receives on average 8 calls per hour. What is the probability that the business will receive exactly 7 calls in 1 hour? So we know how to do these types of problems. So we can clearly see that the mean is 8 and x is 7, since we want to calculate the probability when x is 7. So it's going to be P of x is equal to 7, and that's going to be mu to the x, mu is 8, x is 7, times e raised to the negative mu over x factorial. So if we plug this in, this is going to be .1395865, or we could say approximately 13.96%. So that's the answer for part A. Now, let's move on to part B. What is the probability that the business will receive at most 5 calls in 1 hour? Now, mu is still 8. That's not going to change. But what is x? X could be any number, any whole number up to 5. So we want to find the probability that x is less than or equal to 5. So I'm just going to rewrite it here. So this is equal to the probability that x is equal to 0. Now, just to conserve space, I'm not going to write x all the time. But it's going to be plus the next one where x is equal to 1, plus when x is equal to 2, all the way to when x is equal to 5. So we have to add up the individual probability values. Now, fortunately, there's a quick way of doing this. I'm going to rewrite the formula to show you. So it's mu to the x, e to the negative mu, divided by x factorial. Now, x is the variable. U and e doesn't change. So what I'm going to do is I'm going to factor out e raised to the negative mu, and then write mu to the x over x factorial, because that's the part of the equation that's going to change with the change in x values. So we could say that P, when x is less than or equal to 5, is going to be e to the negative mu, which is e to the negative 8, and then times, we're going to plug in these values when x is 0. So mu is always 8, raised to the 0 power over 0 factorial, plus, now when x is 1, mu is not going to change. It's still 8, but x is that new value. And then when x is 2, and so forth. And then you could just follow the pattern. So this makes it a little easier to calculate the cumulative probability values. So go ahead and type this in your calculator. E to the 0 is 1. So I got 0.191236. So that's a 19.12% chance that the business is going to receive at most 5 calls in 1 hour. So that's it for part B. Now let's move on to part C. What is the probability that the business will receive more than 6 calls in 1 hour? So the time interval is still 1 hour, which means mu is still 8. But now we want to calculate the probability that x is greater than 6, but not equal to 6. So x could be 7, 8, 9, 10, and so forth. Now this can go to infinity, so it doesn't end. How can we find the answer in this case? Well, let's draw a picture. The Poisson distribution has a graph that is decreasing over time. The probability is on the it's on the y-axis. The random variable x is on the x-axis, or the horizontal axis. Now let's say x is 6 at this point. So we're going to split the graph into 2 parts. Let me use a different color. Now let's say that the probability of the student receiving, let's say the probability that the business receiving 6 or less calls is 30%, just to give a number for the sake of illustration. What is the probability that x will be greater than 6? The total area under the curve, which represents the total probability, is 1, or 100%. So if the probability that x is equal to or less than 6, if it's 30%, then the probability that x is greater than 6 will be 70%, because these two have to add up to 100. So on the left side, this represents the probability that x is less than or equal to 6. On the right side, this represents the probability that x is greater than 6. Now, if we add these two values, this is going to equal 1. So if we take this term and move it to this side, we could say that the probability that x is greater than 6 is 1 minus the probability that x is less than or equal to 6. So this is going to equal 1 minus the probability that x is 0 plus the probability when x is 1 all the way up to 6. And I'm running out of space. So this is going to be 1 minus, we're going to use the same procedure that we did in part B. So it's e to the negative 8, and then times mu to the x over x factorial. So mu is still 8, x is 0, and then plus 8 to the first power over 1 factorial plus 8 to the second power over 2 factorial. And we're going to repeat this until we get to 6. So go ahead and type this in. Hopefully you have a scientific calculator, which will make life a lot easier when dealing with problems like this. So I got 0.6866626. So we could say that it's approximately a 68.7% chance that the business will receive more than 6 calls in 1 hour. So the chance is high. And it makes sense because the average is 8. So more than likely, it's going to receive more than 6 calls in an hour if on average it receives 8 calls in an hour.